Applications of the phenomenon of beats. Following are some of the important applications of the phenomenon of beats. 1. The phenomenon of beats is used in the determination of unknown frequencies.
Suppose N2 is the unknown frequency of a tuning fork B. Let this fork B produce M beats per second with another tuning fork A of known frequency N1. As number of beats per second is equal to difference is frequencies of two sources, therefore, N2 equals to N1 plus or minus M.
The positive or negative sign of M can be decided in the following two ways. A. By loading fork B with wax. Suppose frequency of fork A is 256 and it gives 4 beats per second with fork B. The two possible frequencies of B are 256 plus or minus 4 equals to 260 or 252. Attach a little wax to one of the prongs of fork B. It becomes heavier so that its frequency decreases, say to 259 from 260 or 251 from 252. Sound the loaded fork B with fork A and count the number of beats per second. If frequency of fork B were 259, number of beats per second would be 259 to 256 equals to 3. That is, it would become less than 4. If frequency of fork B were 251, number of beats per second would be 256 to 251 equals to 5. That is, it would become more than 4. Hence, we conclude that if number of beats per second on loading fork B of unknown frequency decreases, M would be positive, and if number of beats per second on loading fork B of unknown frequency increases, M would be negative. Note that we may also load fork A of known frequency instead of fork B and repeat the experiment. If number of beats per second increase, M would be positive, and if number of beats per second decreases, M would be negative. B. By filling fork B. When a prong of fork B is filled a little, it becomes lighter and its frequency of vibration increases. On sounding the field for B with work A, we count the number of beats per second. Proceeding as above, we conclude that if number of beats per second on filling fork B of unknown frequency increases, M would be positive and vice versa. 2. The phenomenon of beats is used in tuning musical instruments. 3. The phenomenon of beats is used in ratio reception in many ways. 4. In designing low-frequency oscillators, beats are used. 5. The phenomenon